I'm Shef Baker. I'm a professor in the Material Science and Engineering Department here at Cornell. My group looks at mechanical properties of materials, and particularly we're very interested in thin metal films and their mechanical behavior, which is different from bulk materials, so we have a big research program doing that. Calmetrics makes X-ray fluorescence calibration standards. X-ray fluorescence is a method that lots of companies use and lots of people use to measure materials. Basically, if you have a material, you shine X-rays on it, the X-rays cause the material to fluoresce. That means it emits other X-rays, and you measure the X-rays that are fluoresced, and you can find out what elements are in the material, and you can also use it to determine how thick a layer is. So companies that make thin coatings like to use these machines to measure the coating thicknesses. Calmetrics had been making chrome calibration standards. These are very thin layers of chromium, and these layers the trick is to make these layers very, very thin, and the way their foils had been supplied was they were made by rolling. So this is a mechanical compression process. You can imagine you had a couple of rollers that are rolling like this, and you've got a chrome sheet that you feed in one side, and the rollers press it down and squeeze it down to make it very thin. And so this rolling process is a standard metallurgical process that's used for lots of different kinds of metals. And the problem is that chromium in particular is very difficult to mechanically deform because it's very hard and it's very brittle. And at some point their supplier quit supplying them with this material because it was difficult, and other people could not figure out how to make the rolling work. And so they came to us, and we proposed to try to make an alternate version where we would make these thin layers by sputter deposition. So this is a process that we use in my research group. And sputtering works in this way. You start with a block of solid chrome, you put a gas in here, and you turn it into a plasma. You basically strip off the electrons, makes the gas atoms charged, and then you can use the charged atoms, accelerate them into the chrome target, and then knocks the chrome atoms out, and they drift back through the plasma and land on the substrate where you're trying to grow this film. This is a complicated process. It has lots of different parameters that you can control, but you can make a coating, a chrome coating, and you can control the properties of that chrome coating over quite a range. The difficulty with this sputter deposition process, it's very difficult to make a layer that's thick enough for their calibration standards. The thicker you make it, these films tend to have very high stresses, very high mechanical stresses, and so they tend to crack and peel off and break. And so this was not a common way for anybody to make thick chrome layers. So I had a very good PhD student, Nate Rogers, who worked on this. We used an AJA deposition system that's at the Cornell Nanofabrication Facility. You're looking at a picture of that one here. That's what that machine looks like. And we used that to work out the parameters. And what we did was we figured out a set of parameters that we could use during sputter deposition to make thick films that were fairly stress-free. But then the problem with that is that when you make these thick layers, thick stress-free layers, the surfaces are microscopically rough. And so they appear, when you look at them, they appear dark, they appear gray or even black. So they're not shiny like you expect chrome to be. It's still only chrome, but that rough surface makes it look dark. And so Calmetrics was afraid, and I think they were right, that customers would look at that and think, well, this can't be a good chrome calibration standard because it doesn't look shiny like chrome should look. You're used to seeing shiny chrome on motorcycle exhaust pipes and other things that you put chrome plating on. And so the trick was, what Nate figured out to do was, we made a thick chrome layer that was dark and ugly, and then he used a different set of process parameters to put a thin layer on the top of that was nice and shiny. So it was still all chrome, still met their requirements. And then once we had those process parameters worked out, then we could transfer that to a different machine at CCMR where they could make many of these things at different thicknesses that could provide Calmetrics with some raw material they could use to make their calibration standards. And I think those calibration standards lasted them a couple of years while they were working out a new source for their supply chain. And so that was one way that we could take our fundamental knowledge of material science and turn it into something that could be useful for a small New York company that wouldn't have the resources to do this otherwise.